Hello, ninth graders. Tomorrow, remember, is our live Zoom meeting. We are pushing it to the afternoon. I believe we did seventh period last time, which was 1 o'clock. Let's double check that. Let's see. Here we go. So, Wednesday live classes. Taking very, very long time today. Let's see. 1 o'clock. So, I'll see you at 1 o'clock tomorrow. All right, today we're going to have some fun. We're going to do a little detective work. We're going to study some waves here, but we're going to do a little detective work. And we're going to try to figure out some things about Typhoon Lagoon. Typhoon Lagoon is a water park in Florida at Disney. And they have some pretty big waves, 5.5 to 6 feet waves. They're no joke. They get up there pretty good, as you can see, for a water park. But we're going to try to do a little detective work here, and we're going to try to figure out a few things. One thing I already told you right there, I told you the waves get to about 5.5 to 6 feet. So that's the amplitude. That's how high they get from that equilibrium point, from when it's flat to then that wave comes by. At the most, it's going to be 5.5 feet. Now, it's going to be less the more you are away, but you can see that these waves, they're pretty good size. That's a pretty good wave, all right? When you're up here close, that amplitude's pretty high, and it's a pretty good wave. We're going to try to calculate a few things. What we're going to try to do, our numbers might be off a little bit because we're going to do some estimating here, but we're going to try to figure out the frequency of these waves, the wavelength from crest to crest, and how fast they're going. The velocity, the frequency, and the wavelength. And we're going to try and figure all that out. And we'll do that with a little detective work. Here comes another one. Bam! Right at you there. Now, you can rent this. You can surf there. I think it's like $1,300 for 100 waves. Takes about 2 hours or so. And then you can add more waves to 25 or 30, 25 or 50 waves you can add on to that. People have done that, rented out this wave pool at certain times. You can see the amplitude is much less back here because the wave starts to lose its energy. Well, not lose it, but transferred. All right, let's do a little detective work here. So I have learned that, let's go back. We're going to try to figure out the frequency. Now, frequency is measured in hertz, and that means how many waves per second. All right, hertz. That's Hertz, and it's abbreviated hertz. And the way you do that, and I'm gonna get my phone out for a calculator here because we're gonna need that in a little bit. Get my passcode off. All right. So I know, after doing some research, that make the machine, they do a water drop. They suck up water and then they drop the water. And that's what makes the wave. They drop water. And they do that every 90 seconds. Okay? Every 90 seconds. So to do the frequency, you're going to take 1 divided by the time. So 1 divided by 90, it's 0.01 hertz. The frequency is equal to 1 divided by the amount of time it takes. And it takes 90 seconds. So our frequency is 0.011111. So we're going to say 0.01 hertz. That's the frequency of the waves at Typhoon Lagoon. Okay. What do you do with that? Well, with that, and some other information, we can figure out the velocity. How fast is that wave going in this pool? How fast is that wave going? It's going pretty good, right? But how fast? Okay. How fast is that wave going? All right, we know it's about 5.5 feet. We know there's going to come about every 90 seconds. The frequency is 0.01. But how fast is it moving? Well, here's where we have to do a little detective work here, because in order to do the speed, we need to know the frequency, which we just got. It's 0.01, and the wavelength. How much between one wave and the next? So here's where we're going to do a little detective work. I brought up a picture here. All right. Here's one wave, and here's the next. All right. Now, this is when it's cranked up for a little bit. It's doing a little more. Well, we're not sure exactly, but we can do a little detective work here. All right. So we need to figure out the distance between here and here. Okay. And let's see. This set of staircase might help us, because a standard staircase, every step in is 11 inches. 11 inches. So if we were to get an idea from here to here, we can then estimate from here to here and here like this much. So if this is 1, 2, let's see, how many steps do you think this is? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's about 18 steps. Maybe there's some down here. Let's call it 20 steps. And if it's about 11 inches, that's about 20 feet. Let's call it 19 feet. So this distance is 19 feet, okay? From here to here, we're estimating 19 feet. And that seems about right, okay? Call it 19 feet. So that would be about this far. Well, there's another 19 feet right about there, right? So let's call that 19 and 19, 38. And I would say it's about another, I don't know, maybe 6 feet here. So 19, 19, and 6. 19 plus 19 plus 6. We're at 44 feet. And then this, we're talking 19, so that would be about 19. 46 plus 19. And then this would be about another 19. And there, about another. So that's about, it says 103 feet. So 100 feet. Does that look like it's about 100 feet? I would say so. A third of a football field. 3 of them together would be a football field. I would say so. All right, so let's go with 100 feet and let's convert that to meters, because we have to do meters. Feet to meters. When we had 103 feet, approximately. It's about 31.3 meters. So that's our wavelength we're going to go with. The distance between wavelengths is about 31 meters. So with that, velocity is frequency times the wavelength. And we know our frequency was 0.01 hertz. And we're going to multiply that by our wavelength, which we think is about 31.3 meters. 31.3 meters. So if we multiply that, 31.3 times 0.01, we get about 0.3 meters per second. .3 meters per second. Now let's convert that to miles per hour. Meters per second to miles per hour. 0.3. That's going about 0.6 miles per hour. And that would make sense. You wouldn't want it hitting you any faster than that. 0.6 miles per hour. We're looking at a speed, the velocity, of 0.6 miles per hour. Okay, so how did we get there? First, we found the frequency. We know that a wave happens every 90 seconds. So we take 1 divided by the number of seconds. So that got us our frequency, 0.01 hertz. How many waves per second? 0.01. Then we took that velocity, to find the velocity, we took our frequency and we multiplied it by our wavelength. Now we estimated our wavelength by knowing what we know about steps. A standard step, it goes up 7 inches and in 11. A rise and a run. Up 7, in 11. 7, 11. So we estimated our wavelength here. And when we got our wavelength, we were able to say the frequency times the wavelength is 0.3 meters per second, and then we converted that to 0.6 miles per hour. That's a lot. Well, you didn't see like, well, that's not really fast. But you remember, that's a 6-foot wave of water. Do you want a 6-foot wave of water hitting you any faster than just over half a mile an hour? I would say no. And having been in that pool, you don't. It's a lot of water hitting you. The last thing we can figure out is if you had the velocity and you had the frequency, you could figure out the wavelength. If someone just told you the other two, if someone told you the velocity and the frequency. So if they gave you the frequency and the velocity, you could figure out the wavelength, which we figured it out by guessing from that picture, from the scale. So things you can figure out with waves is the wavelength. Take the velocity divided by the frequency. If you want to figure out the frequency, you take 1 divided by the time it takes from one wave to hit to the next. And if you wanted to figure out the velocity, you could take that frequency times the wavelength. All right? All right, well, that's it for today. And we will see you tomorrow in the live meeting at 1 o'clock. Period 7, 1 o'clock.